Hey there, this is part two. This is tonight's homework, May 8th, Tuesday night. And I had started the recording on the first one and then had to go back and review, stop and talk, and then I'm back and now I got to start over. So let's take a look at the first one. Spring rain is 20 degrees Celsius. Boiling water is how many times as hot as a spring rain? Okay, so now we're looking at times. So I have to look at it's how many times. So is it 5 times the 20 degrees of spring rain? Is it 4 times as hot as the 20 degrees of spring rain? 3 times as much as the 20 degrees of spring rain? Or 100 times as 20 degrees of the spring rain? So now what I did was I had to do mathematics, and I did 5 times 20 equals 100. Well, I also wrote out boiling point. Boiling point, I know, is at 100 degrees Celsius. Some of you would probably have already moved over to this one because you're like, oh, wait, boiling point, and you would see boiling point is 100 degrees, immediately circle it. But that's not what it's asking you. It's saying how many times is it as hot as the spring rain? And so we had to see which one is equal to 100 degrees. So the answer is D because it's 5 times as much as the spring rain, which was 20. So this is spring rain. And so it's 5 times as much as that. So 5 times 20 is 100, and the answer is D. Let's look at number 2. When Coralie woke up, she noticed that she had snow. The outdoor thermometer read -7 degrees Celsius. Later in the day, she noticed that the snow has begun to melt. What is a possible temperature change that occurred? Okay, so what was it? Couldn't have been -7 because that means that the temperature changed at -7 degrees, so that's not going to work out. Okay, so she noticed that the snow has begun to melt. All right, so now we're looking over here at if it was at -7 and it changed at 5 degrees. Here, if it changed at -7 degrees, we haven't learned negative integers, but if you add a negative and a negative, that negative stays the same, and so 7 plus 7 equals 14, and it only decreases the temperature by -14 degrees. Okay, so that's not a possibility. So you're now learning tonight negative integers. Congratulations. You have a -7, and you're going to add a +5 to it. It makes it, we keep the negative because that's the larger number. So it's a negative and a positive, it'll still stay the negative. So it's a -7 minus 5 is 2. So it's still below because melting begins at 0 degrees Celsius. And right now it'll be at -2 degrees Celsius. This would have been at -14 degrees. If temperature changed 1 degree, I have -7. And that becomes a -6. And that won't work because it's still below. But if it changed 10 degrees, and this is where I got my 10 minus 7, well, 10 minus 7, which is also because I put my larger number, if I add my -7 to it, I'm going to take that away, and it becomes that 3, so it started to change at 3 degrees Celsius. Okay? And so the best answer is at 10 degrees Celsius because then I brought it into the plus area, which was at 3 degrees. Plus the minus negates it at 3. Okay. Confusing, see me in the morning. Okay. Next one. Jack performs an investigation with several pieces of ice. Now he places the ice in a chamber that can very quickly add and remove thermal energy. That's cool. He records the state of matter. He records the state of matter after each temperature change. He raises the temperature of the ice at 78 degrees. Now, he's recording the state of matter. He raises the temperature 35 degrees. He drops the temperature 47 degrees Celsius, and he lowers it another 64 degrees Celsius. Which data correctly shows the states of matter after each temperature? States of matter, my friends, is solid, liquid, and gas. So we're going to eliminate the temperature ranges because it's not asking us the temperatures that he was doing it. Now we're left with liquid, gas, liquid, liquid, and then this is solid. So now I have to take, first of all, he raises the temperature of the ice at 78 degrees Celsius. So when he raises it to 78 degrees Celsius at ice, it turns to a liquid. Then he raises the temperature again. So I added 78 plus 35, and that got me 113 degrees. And so it's above the boiling point because I have freezing, I have boiling point is at 100 degrees Celsius, which means that it began to boil and it went from a liquid to a gas. Then it said that he drops the temperature 47 degrees. So now I have to take 47 degrees. I have to take 47 from 113. That leaves me with 66 degrees. Changes that gas to a liquid because it's taking heat away. Makes it back into a liquid. Then it said that it dropped another 64 degrees. So I had my 66 minus 64. That's 2 degrees Celsius. Now, previously it was like, oh my gosh, it's super cold. It's a solid, right? No, because I remember the freezing point, when it turns to a solid, is at 0 degrees Celsius. So it does not change into a solid just yet. It still stays a liquid. So we had a liquid, and a liquid does not change to a solid. It needs to be at 0 degrees Celsius, and it was at 2 degrees. Okay? So let me know if you had any problems with that one. Pause it, process it, go back if you need to. All right, this one here, we were talking about buoyancy. So we covered density. And so if we took a cube, and this says an object is considered neutrally buoyant when it has the same density as water or the substance is suspended in. So it doesn't either sink, it doesn't float to the top, it stays in the middle, just like here. So the result of this is that the object seems to float without rising or falling. Water has a density of exactly 1 gram per cubic centimeter. So an example, 27.5 or 27.5 grams of water would have a volume of 27.5 grams of cubic centimeter. So when placed in water, a buoyancy cube stays at exactly the same height as you placed it and does not rise or fall. So it'll be the height between here and here, and here and here. They're the same, which means that it's right in the middle. Okay, so now if we take this buoyancy cube, which is going to be a sponge-like type of cube, and we're going to label each result as M for more dense, L for less dense, S for the same density as the original cube. Also list the object's mass and volume, and here you're going to have mass and volume, and we're going to show the arrows. Did the mass increase or decrease, showing of the arrows down, or did it stay the same? Did the volume increase or decrease or stay the same? So let's look at this first one. Obby squishes the cube so that it now takes up half the space it did before. So he takes the sponge cube, right, and he squishes it, and it puts it, and it's in the water. When he squished it together, it became more compact, so it became more dense, and we're going to put an M right here. The mass in that sponge never changes. Remember, it stays the same. Didn't take anything away, didn't add anything inside. It stayed the same. So the mass is still the same. The volume, however, decreased because you squished it. So it's holding less. The capacity is less. Now let's look at the next one. Jaden takes a cube and is able to stretch it so that it now takes up 3 times as much space. So if it's taking up 3 times as much space, is it going to, and it means that it's going to have more air pockets in there. So it makes it more or less dense. It makes it less dense because there's now more air pockets. Open it up, and now the mass still stays the same because whatever's in it is still in it. Doesn't matter if you stretch it or squish it, still the same amount of mass. However, the volume, because it's been stretched out, it's going to absorb more. So it's going to hold more. So that increases. Okay? Saucy cuts the cube exactly in half and places one of the halves in the water. Okay? So he takes the cube, cuts it in half. Doesn't squish it, doesn't stretch it. Just cuts it in half. What happens to the density? It's going to stay the same. Doesn't matter whether it was cut in half, it was one piece. You didn't stretch it, you didn't squish it, it just cut it in half. The density stays the same. It's going to still stay in the same place, whether it was half of the cube or part of the cube, or all of the cube. The mass itself, though, decreased because you only have half of the cube, only have half of the stuff. And the volume itself also decreased because you took half of the capacity away. Riley combines 2 cubes but compresses them so they take up the same space as before. Now he has 2 cubes but compresses them so they take up the same space as before. Okay, what happens to the density? Well, he's got 2 of them. Whether he squished them together, he's squishing them so they're more compact. So there's more dense. It's more dense than it was before. With Riley, when he combined 2 cubes, it's double the mass. So the mass increases. But when he compresses them together, where it was before, it's going to hold the same amount of volume. So the volume doesn't change because he's compressed those, so it's going to only hold the same amount. But you've doubled the mass, and you doubled the density because now it's more dense than it was before. Okay. Jacob takes 2 cubes identical to the original cube and attaches them together and places them on the water. Okay, so he takes 2 cubes identical to the original cube. So he's now got 2 cubes, and he's attached them together and places them in the water. So he just added another cube like this. He added another cube to it. You can see that. The density doesn't change because he just attaches them together and places in the water. So he's just attaching those 2 cubes together and puts them in the water. Doesn't squish it, doesn't stretch it. He just places them together. So the density is the same, but the mass, because you have 2 cubes that are together, the mass increases. And when they're together, the volume itself increased as well. Caroline magically removes the stuff inside. That'll be interesting. But you hear the word magically. So somehow, some way, she removes the stuff inside the cube without changing the cube size. So the density, so now with inside the cube, she took the stuff out, leaving the size of the cube. So she was able to remove all of this inside. Stays the same. Now it's less dense.